Yeah. Tell me, how do you find the dimensions of epsilon naught?
Hello. So, it was a question how to find the dimension of epsilon.
Yeah.
Okay. So, sir, k is equal to 1 by 4 pi epsilon naught, and f that is force is equal to k q1 q2 by k q1 q2 by r square, and force of unit of f is n. Unit of k is c, and unit of r is meter. So, mean you take the q's and r's that side, we'll be left with k, unit of k. And when we get the unit of k, it's just the inverse of, because k is inverse of 1 by.
Good, correct. But you are telling me unit. I'm asking you dimension.
Okay, so sir, each unit will have dimension like m, l, a, t.
Fine, fine. Just tell me what is the dimension of Coulomb?
A t to the power minus 1.
A into t power 1.
Yeah.
Not it's plus 1, not minus 1.
That's what I said. I'm sorry. Okay, fine.
It is 80.
It's 8. Okay.
Because current is charge by time. And you want charge.
Charge. So 80.
Yes, 80. Okay.
Okay.
If distance is doubled, what happens to electrostatic force of attraction?
If distance is doubled, the force of attraction becomes 1 by 4, f by 4.
Very good. Why is Coulomb law called a central force?
Because it's the force between the two charges, and it's the same. Charge of 1 on 2 is the same as charge of 2 on 1.
Then it should be called a symmetrical force. I didn't say symmetrical, I said central.
I'm not sure.
Okay, because it acts between the centers of the two charges.
Okay, so okay.
So if the charges are big, you will take the centers, distance between the centers. Read these books called Together With or something. Okay.
Okay,
Why is repulsion a sure parameter of presence of charge but not attraction?
okay. So when there's one charged body and another uncharged body.
Very good. You know the answer. What is superposition principle?
Superposition principle is. You want me to tell the formula? Right?
I want you to explain to me what is superposition principle.
Okay, so when many things, when multiple forces or electric fields are acting on the same point, then it gets added.
Say vectorially.
It may be in the same direction only. Sorry?
I said you say they get added vectorially. Don't say they are just added. Say they are added vectorially.
Okay, but yeah, fine.
Okay. In the vector form of Coulomb's law, is there an R cube in the denominator?
Is there?
It's there, yes. Is there? Yes or no?
In the vector form of
Coulomb's law.
Okay. So
is there an R cube in the denominator? Yes or no?
No. Yes, it's there. It's there.
So why it is 3? Why it is cube and not square?
So it is R. I'm not sure why, but I know it's there. In the vector form, it's there.
So why the real question, the final question is, why is it there?
Okay, so the direction, the total charge is magnitude into direction.
The total force.
Magnitude in the direction.
The total force.
Sorry, sir.
I'm saying the total force is magnitude into direction.
Yes. So when we take magnitude in direction, so magnitude. So total force is magnitude into direction. So magnitude will also be R, and the direction will also be R cap.
You need to read the Coulomb's law again, okay? Your answer is not up to the mark, okay?
So, but where did we discuss? Or maybe I missed the classes because the first few classes.
Yeah, so I think recording देख लो फिर या फिर just ask me in some spare time, okay?
Okay, and like, do you have any file for it, like, or the like a blog or something?
What I have, everything is in the spreadsheet. You have the
Okay.
spreadsheet, yes or no?
Yes, sir. Yes, sir.
The recordings are in the spreadsheet. There are, take a piece of pen and paper, and there is a charge q on 0, 0. Charge q at 0, 0. Okay.
Okay.
And 4q at 10, 0. Both are positive charges. Where do you think is an equilibrium point? When I say equilibrium point, I mean where electric field might be 0. Or
you want the exact point, or
no? First, you tell me where do you think it's lying? Like approximate, where do you think? Idea.
okay. So the equilibrium point will be somewhere close to Q, because the charge it should be away from 4Q.
Okay, left of Q or right of Q?
It should. You said both of them are positive, right?
Yes. So left of Q or right of Q?
So right of Q.
Good. Good. Okay. The second question is, can you find this point exactly? Your voice is not coming. Hello. It's freezing. Hello.
Hello. So
Yeah.
can you hear me now?
Yeah, I can hear you now. Can you find this point exactly?
Yes, sir. You can find the point exactly.
Okay. How do you do that?
So the electric field at the point by Q and 4Q should be the same.
Very good.
So we write.
Okay, fine. Understood. You know how to do it. Now you tell me, after you find the equilibrium point, and suppose it is at some point, is that equilibrium stable or unstable?
It is unstable.
Unstable. Are you sure?
Yes, sir. Because if you push it to one side, it's just going to go towards that side.
No, I don't think it's unstable. It's stable. Think about it again. It's stable. Okay. Yeah, it's stable.
Okay, yeah.
Catch up on stable and unstable equilibrium again. Okay. Due to an isolated charge, due to an isolated positive charge, where do the electric field start and where does it end?
It goes away from the charge.
Repeat your answer. Your voice is breaking.
So for a positive charge, the electric field starts at the point and goes away from the charge.
Where does it end?
It ends at the negative charge.
There is no negative charge. I said isolated positive charge. There is only one positive charge.
So it doesn't end.
Okay, so when something doesn't end, where does it end?
Infinite.
Infinity, yes. Infinity is the answer. Okay, now Which one? 25th.
Hmm.
25th.
Yes, sir. Which one? Sir, it's C.
Why? जल्दी से आंसर बोलो.
Sir,
Why?
cannot. Yeah, sir, because it's not a starting nor an ending point.
Okay. Sixth.
Sir, at 3, option B.
Option B.
Yes, sir.
Okay. And 3. Question number. That's correct. By the way, third.
So it will be towards A, B, along diagonal B, D, option B.
That's correct.
What about the hexagonal, the diagram?
That was also correct. No? I said it's correct.
Okay, no, I think I just heard. Okay, so 23.
23. Only the A part. Tell me whether it's correct or not.
Okay.
Just tell me the A part.
Sir, it won't.
What?
I mean, then which of the so A is incorrect.
Incorrect.
Yes, sir.
Plus Q minus Q. Yeah, it is incorrect. Plus Q and minus Q. No, it is incorrect. Correct. 1 minute. Your time is over, but the next person hasn't got Tarun. इसके बाद 7:15 to Tarun. 7:30
No, sir, he's
Tarun.
new. I mean, he's in the house only.
So why hasn't he joined?
I think he'll join with the same device. He'll join from the same device.
Okay, give it to him.
Okay. Sir, and score for this or is just
Pardon?
like what about the score? I mean the marks for this.
Oh, I have given the
Or
marks. You'll receive it once everyone is done. And were you using an
okay, sir.
earphone or were you using speakers? You're using an earphone, right?
Using an earphone.
Fine, fine. You can leave. Give it to him.
Yes, sir.